We're going to take a look at equivalent trig functions, which will help prepare us for the rest of the lessons. Now, we should be able to identify equivalent trig relationships now that we know the transformations of sine and cosine. So when we look at this function, how would you identify this function? As you can see, it starts at 0, 0. It looks similar to sine. However, we know that sine looks like this. So how would we describe this function then? Well, it is a sine function. However, it's been reflected. So we would say that y equals negative sine x. Now, what if I asked you to describe the same function but using cosine? So we know that cosine starts at 0, 1, and then it goes down, passes through pi 0, and then comes back up. So what is the difference between these two functions? What would you say is the difference? So we can say that this function, if it's a cosine function, it has been not only reflected, but it has been shifted. So if we were to look at our cosine function here, we know it's supposed to start at 0, 1. So if we were to use this point here, it's been reflected, but it's also shifted. So to shift it back, we would describe this as x minus pi over 2 because it's been shifted by pi over 2 to the right. Now I can also use this point here to describe my function. So it would be a cosine function, however, it has been shifted from 0, 1 to negative pi over 2, 1. So what is the phase shift here? What would I have to do to get it back to its original place? Well, this would then be y equals cos, and then x plus pi over 2. So we can use horizontal translations that involve multiples of the period of a trig function, and they can be used to obtain two equivalent functions with the same graph. Okay, so just to review even and odd functions, so we know that f at cosine theta is even because its graph is symmetrical on the y-axis. So if we take a look here, this function can be reflected on the y-axis. Now, when it comes to f at theta equals sine theta, it's an odd function because it has rotational symmetry about the origin. So we would have to perform a double reflection of sine for it to become its original. And then although we're not looking at tan theta, we can see that it's also an odd function. So a new term here is the cofunction identities. Now, cofunction identities, they describe the trig relationships between the complementary angles of theta and pi over 2 minus theta in a right triangle. So if we look at theta and we look at pi over 2 minus theta, sine of theta, so remember sine uses the opposite over the adjacent. So the opposite over the adjacent would be cosine pi over 2 minus theta. If we look at cosine theta, we know that cosine uses adjacent over hypotenuse. So that would be sine pi over 2 minus theta. And then tan theta would be cotangent pi over 2 minus theta. So cofunction identities, they're just describing the relationship between the complementary angles. Okay, when we're talking about complementary angles, remember we're looking at the degrees here. So for each of these trig ratios, we're going to state an equivalent trig ratio using the cofunction identities. So the first one we're going to look at is cosine pi over 10. So we know that cosine theta is equal to sine pi over 2 minus theta. So now we need to take a look at the equivalent. So here, if it's equivalent, we have a denominator of 2. We want the denominator to be 10. So we're going to multiply this by 5, which means we're going to multiply this by 5 as well. And then our theta is going to be pi over 10. So what we're going to have now is sine 5 pi over 10 minus pi over 10. So now we have sine of 4 pi over 10, which is equal to sine of 2 pi over 5. So we can state that cos of pi over 10 equals sine 2 pi over 5. So let's try the next one. So we have sine 3 pi over 8. So we're going to be using cosine, the equivalent, pi over 2 minus theta. So we're going to have cos pi over 2 minus 3 pi over 8. So what do we have to do here? We have to multiply by 4. And when we multiply by 4, we're going to get cos 4 pi over 8 minus 3 pi over 8. And we are left with cos pi over 8. So sine 3 pi over 8 is equal to cos pi over 8. And next we have negative sine 5 pi over 4. So for sine, we're going to use cos. So this is going to equal cos pi over 2 minus 5 pi over 4. And then we know we have the negative in front. So this is going to equal negative cos 2 pi over 4 minus 5 pi over 4. So we're left with cos 3 pi over 4. So there's our equivalent. Now, if I asked you to state 3 equivalent ratios between 0 and 2 pi for the following, so if I gave you cos of pi over 4, well, cosine of pi over 4, first let's talk about which quad that would be in. So we know pi over 4 is an acute angle, so it's going to be in here. But for quad 2, we would have pi, this is pi here, minus pi over 4. So that would be 4 pi over 4 minus pi over 4. So we'd be left with 3 pi over 4. Now in quad 3, what would we have? We would have pi plus pi over 4. So that's going to be 4 pi over 4 plus pi over 4, which gives us 5 pi over 4. And then finally in quad 4, we would have 2 pi minus pi over 4. So that is going to give us 8 pi over 4 minus pi over 4, which is 7 pi over 4. So this lesson here is going to help us with the next few lessons when we're looking at using equivalent ratios. It's going to help us with compound angle formulas, with double angle formulas that we'll be looking at, as well as when we're using the trig identities.